Watch as we learn how to graph sines and cosines. This thing is called a wave, or a sinusoid, or a graph of a sine and cosine, and that's what we'll be focusing on right now. The distance from the middle to the top of a wave, or from the middle to the bottom, is called the amplitude. The distance between wave crests is called a period, or sometimes called a wavelength. A period can also be the distance between two equivalent points on the wave, as shown here. Generally, in most math classes, you'll graph either one or two cycles or periods of the function because they go on forever. You can't graph the whole thing. Here's our first example. There's a four-step process. First, you want to set up a table with appropriate x values to plot. Start with 0 in simple problems like this, and end with whatever the period of your function is. The period for sine and cosine functions, we're doing cosine here, is 2 pi. But you want 5 lines on your table, so you want to get the midpoint between 0 and 2 pi. The midpoint formula is to add and divide by 2, so you can do the algebra, but also it's kind of common sense that pi is the midpoint between 0 and 2 pi. From there, you want to find the midpoint between the midpoint and the start and end. So here we'll find the midpoint between 0 and pi. That may be obvious to you. The formula is add and divide by 2. That's no mystery. And finally, you'll want your x value to be the midpoint between pi and 2 pi, which you can use the formula there as well. Step two is going to be plug in all those x values into the given equation. So plug in 0. The cosine of 0 is 1, so that's 3. Then plug in the next x value. Remember, pi over 2 radians is the same as 90 degrees. Cosine of 90 is 0, so that result is 0. You continue to plug in the different x values to find y. Step 3, once you've completed your table, plot the points and sketch a wave. When you plot points, remember to consider the fact that pi is 3.14. And you may need a calculator to figure out those decimals. But if you plot the 5 points in your table, you'll get these. I recommend pausing and seeing if you can see why I chose the locations I did. And now that you're convinced of that, we'll draw a wave through there, and that is the graph of 3 times cosine x. Depending on your course and the situation, you may have to duplicate that and draw a second period. The second period will be exactly like the first, just a replication tacked onto the end. Remember, this graph goes on forever, but drawing 2 periods of it should be sufficient. And lastly, after the 4 graphing steps, you're typically asked to find certain key points on the graph. So suppose we were asked to find this point here. Well, that came from the XY chart, so we know what that is. The point at the top of a wave is called a local maximum. Suppose we were asked to find this point here. Well, that point also came from the table. The crossing of the x-axis is called an x-intercept. Sometimes you'll be asked for points such as this one that are beyond the table. Here's where we can make use of the fact that the period is 2 pi. We know this point from graphing the table, and since the period is 2 pi, I can just add 2 pi to the x-coordinate, and I'll get my new coordinate here, showing me the coordinates of that point. The bottom of a wave is called a local minimum. And finally, suppose we were asked for this point here. Again, it's beyond our table, but it corresponds to this point, which we know from our table. And because the period is 2 pi, we can just add 2 pi to that x value and get a new x value. Watch the algebra here as I add 2 pi. Remember from earlier classes that you need a common denominator to add fractions. So I want them both to be 2, and therefore the numerator would have to be 4 pi, giving me the x-coordinate here of that x-intercept. Thank you for watching.